Okay, so I thought maybe we just start off simple, try and learn how to use the table and everything. Here is a sample problem for you guys. There we go. So we're given that a population has a mean of 50 and a variance of 49, and we're talking about ages of people in a population. So what would be the probability of us picking someone at random who is 25 years or older? So if you want, you can definitely draw a graph of this. I'll just draw one so you guys can sort of visualize it. So it's normally distributed on the graph. We have a mean at 50, which is also our 0 point because we're going to convert it into z-score. Put some labels on it. Okay, so here's our graph. It's normally distributed. 50 is up the middle, which is also our 0 point when we're talking about z-score. So what do we do from here? Well, first you want to try and calculate your z-score, which, if you remember the equation, it was z is equal to x minus mu all over sigma. So our z-score then would be equal to x, which is what we're trying to find, so 25, minus mu, which is our population mean, which said was 50, all over our standard deviation. And so I did the problem when it gave us variance because that's how we're going to get it in class. So you would take it all over the square root of 49. Like that. There we are. Okay. So you end up getting negative 25 all over 7, which when you figure it out is about negative 3.57. So when you're finding z-scores, you're going to want to get it in the 2 decimal places, so you can look it up on the table, rounding, I believe it's up when necessary. So we get a z-score of negative 3.57, so you can kind of graph that on here. It's going to be this shaded area right there. Hopefully you guys can see that right there. That little tiny shaded area is our z-score. So what does this mean? Well, we look it up on the table. We look up negative 3.57. If you guys don't know how to use the table, it's kind of stupid. It's on page A38 in our book, and I can try and show it to you guys. Okay, so here's our table, and it's not really coming up on here, so I guess that won't work. But anyway, going vertically down the table, you'll see z-scores on this page A38 that are negative. So you look for negative 3.5, it's towards the top. And then you have to go over to negative 0.07 because that is our second number in the decimal place. So when you find that intersection between negative 3.5 and negative 0.07, you get 0.0002, which is our percent of our population up to the z-score of negative 3.57 from negative 4. So it's a really small amount of people. So if you were to stop there on an exam, you would get it wrong. You'd probably just get half credit because the problem said, what is the probability of selecting someone that is 25 years or older? So based on our little table, what we found that's shaded was the probability of getting someone that is between the age of 0 to 25. So the probability of getting someone from 25 and older is all this area that is unshaded. And you can find that by just taking 1, our entire data set population, minus 0.0002, and you end up getting 0.9998, which is like 99.98% of your population will be 25 years or older, based on this question. So that would be your final answer to the problem. Sorry, I keep kind of jumbling the table around the camera. I've never used one before, so I'm just getting used to like moving it around to show it on there. So that's an example of what we use to find the z-score. What does it mean? How does it look on a graph? Why do we care to find it? I think I'm going to do another problem quickly from our book, in which you have to find the area between two different z-scores. So, trying to find the page quickly. Let's see. Okay, so the question is question number 4.61, and it's on page 123 in the book. And the question is, what is the area under the curve between a z-score of 0 and 1.43? So we're trying to find the area under the curve between those. So if you draw a graph, and 0 is right there, 1.43 is about here. Draw a second line. So we're trying to find the area. It looks like Halloween. Between this shade and red. Okay, so we're trying to find that red shaded area on our graph. Okay, so we look up on the table a z-score of 0, and that turns out to be 0.5 on our table. And then we look up 1.43 and we get 0.9236. So I'm sure you already know what to do. The area in between that, then, the probability of x, would be our z-score of 1.43, which was 0.9236, subtracted from the z value of 0, which was 0.500, and we get an answer of 0.4236. Okay, I'll show it. So that is what we end up getting right there. So what that means is that roughly 42.36% of our data falls in line right there. So obviously my graph is not very scaled appropriately. It looks kind of like crap. But you get what I'm trying to do. So that's pretty much that on normal distribution and its applications with z-score. We're going to be using pretty much z-score for, I think, the rest of the semester. I'm going to put another video on here with what we started towards the end of last week on Wednesday, Thursday, and Friday with the